In this week 13 video for Regents Review, we are going to talk about sequences. Now with sequences, there's a lot to think about in terms of whether it's arithmetic or geometric, and then how those equations are going to be different for them. But in this one, we're just going to take a look at a couple practice problems to help you remember some of these main ideas. So in this first problem that I have, it says, what is the common ratio of the geometric sequence? So because we are dealing with a geometric sequence, we are always going to have a common ratio. Arithmetic sequences have common differences. Geometric sequences have common ratios. So the way that we determine what this common ratio value is going to be is we always take the right side or the right number, dividing it by the number on the left, or the term on the left, I should say. So if we have that our first term is equal to 5, our second term, we're not sure what it's equal to, but our third term is equal to 245. What I'm going to do here is divide my right term, which in this case is 245, by the term on the left, which is 5. And that's equal to 49. Now, 49 is how I'm getting from 5 to 245, but we want to know what the common difference is for the entire sequence and not like just how you get from the first term to the third term. So in order to figure out that, I need to say, well, there's this missing term here. So since it's only off by a one term, I take the 49 and I can take the square root of 49, and that's equal to 7. And that will be my common ratio for this problem. Now to double check this, to make sure that 7 is indeed the common ratio, you can do the multiplication out and say if I'm going from 5 times 7 is equal to 35. So that would be my second term. So that would mean that 35 times 7 should equal 245. So I get 35 times 7 is equal to, 5 times 7 is equal to 35. 7 times 3 is 21, plus 3 is 24. So I get 245, and my answer checks. Our next problem for number 10 is going to be to write the first 5 terms of the recursive sequence defined below. So in this problem, we are given the sequence, and it wants us to determine the first 5 values of the sequence. Now, in a recursive sequence, it really has to do with the notation which is being used to define the sequence. So here we are given that our first term is going to be equal to 0. So if I want to know the first 5 terms, 1, 2, 3, 4, 5, I know that my a sub 1 is equal to 0. To find my a sub 2, I'm going to use this given recursive formula sequence here in order to find that. So what I'm going to do is I'm going to plug in the values that I know and then calculate it. So it starts off as 2 times a to the n minus 1. Well, if I want to find a sub 2, then I need to plug in a sub 1 for this value here, the value just to the left of it. So it's going to be times 0. I'm going to square that and then subtract 1. So that turns into 2 times 0 minus 1, which is equal to a negative 1. So the second term of my sequence is equal to negative 1. For my a sub 3, I'm going to, again, just plug my values in. So it's going to be 2 times my a sub 2 value of negative 1 squared minus 1. Watch your signs here. So I get a negative 1 squared is positive 1. Positive 1 times 2 is 2 minus 1 is equal to 1. So my a sub 3 term is equal to a positive 1. For my a sub 4, it's going to be 2 times my a sub 3 term of 1 squared minus 1, which is equal to 2 minus 1, which is equal to 1. For my a sub 5, hopefully we've seen a little bit of a pattern here, but it won't always happen with every sequence. So if I look at this, I get 2 times my a sub 4 value, which is 1, squared minus 1 is equal to 1. So 0, negative 1, 1, 1, 1 would be the first 5 terms of our recursive sequence.